Page 2 of properties of curves. We're going to do part C of the last problem. Find k if the tangent to this function at the point where x equals 2 has gradient 4. Okay, so when does the derivative of this function have a value of 4? So first we need to find the derivative. The derivative of that function would be 2 times 3x squared plus, remember k is just a number, so we just treat it as a coefficient. K times 2x minus 3, the derivative is 0. Simplify. 6x squared plus 2kx at x equals 2. When x equals 2, this is equal to 6 times 2 squared plus 2k times 2. Simplify. 6 times 4 is 24 plus 4k. When is that derivative equal to 4? 24 plus 4k equals 4. 4k equals negative 20. K equals negative 5. 4a. Consider this curve where a and b are constants. The tangent to this curve at the point where x equals 0 is 2x plus y equals 6. Find the values of a and b. Now, this is not an easy problem, but just don't lose sight of the fact that the curve and the tangent line have the same x and y coordinates at this special tangent point, and they have the same slope. They're all equal, so take advantage of that. So we know that the x value is 1 for both of these, the blue curve and the red line. We know that the y coordinate can be found by plugging in x into either one of these. Now, since this one has unknowns in it, we're not going to use that one. We're going to use the red equation. So 2x plus y equals 6 can give us the y coordinate of this common point. So let's put in 1 here. It's 2 times 1 plus y equals 6. 2 plus y equals 6. Y equals 4. Oh, so we already know that the y value here is y equals 4 for both the red line and the blue curve. What else do we know? We know that the slope for both are the same at that point. Now, the slope for the blue curve is kind of unknown because we don't know what a and b are, but we could find an expression for the slope. Wouldn't it be the derivative? 2x plus a, right? Because the derivative of ax, if a is a number, is a. The derivative of b, if b is a number, is 0. So this is the derivative, and we want to know what the derivative is at x equals 1. So we can plug in x equals 1, and we'll just get 2 plus a. So the slope here at this special point happens to be 2 plus a. Wait a second, we also know the slope from looking at this red equation. We know it's a line, so we could put it into slope-intercept form by putting the 2x on the other side, and we know that the slope of both the red line and the blue curve, the gradient is negative 2, because look, negative 2 in the position of the slope. So 2 plus a is negative 2. So we can find out that a is actually equal to negative 4, right? Now that we know that a equals negative 4, and we know that the y coordinate is 4, we might be able to use this equation to find out what b is, right? Let's write it all down here. So we know that at this particular point, which should make this equation true, y is equal to 4, x is equal to 1, and a is equal to negative 4. A is equal to negative 4. So now we can use that to find b. Let's fill everything in. So instead of y, we're going to put 4. Instead of x squared, we're going to put 1 squared. Instead of ax, we're going to put negative 4 times 1, and then plus b. 4 is equal to 1 minus 4 plus b. 4 is equal to negative 3 plus b. B is equal to, add 3 to both sides, 7. Okay, so we found the values for A and B by knowing that the x-coordinate, the y-coordinate, and the slope at this point for both the red line and the blue curve are the same. Okay, that's a difficult problem. C, show that the equation of the tangent to this function at the point where x equals a is that. Okay, so why don't we just go through the regular procedure to find the equation of the tangent line? Now, they gave us the function, and they told us the point where they want the tangent line to occur. So this is usually the time when we write down point slope form and we start going through our little procedure, right? Now, we should end up with this, but we're not going to use this to find our answer, okay? So there's 3 ingredients, y1, x1, and m. Well, they tell us, even though it's a constant, it's not a number, we can treat it like a number, so we can put a in for x1, right? We can find the y1 value by putting a into here. So y is actually equal to 2a squared minus 1. So we're going to put this expression into y1. The last thing we need is the gradient. So we can find the gradient by taking the derivative, right? 4x to the first minus 1, the derivative is 0. So it's just 4x. Our x value we know is a. So our derivative or gradient at the point A is 4a. So we can put 4a here. Now let's rewrite it. Y minus 2a squared minus 1 equals 4a times x minus a. Now let's distribute things like the negative sign and distribute the 4a. So we have y minus 2a squared plus 1 equals 4ax minus 4a squared. First thing I notice when I simplify this is I have an a squared term on both sides. I'm going to add 4a squared to both sides. Add 4a squared, add 4a squared. As a result, now I'll have y plus 2a squared plus 1 equals 4ax, period. Okay? And then last thing is, to make it look like the end result, I need to subtract y from both sides. So now I have 2a squared plus 1 equals 4ax minus 1. Okay? That's what we wanted. We are done. Okay, number 5. Find the equation of the tangent to, and there's 2 problems here. So let's do this one first. We have a function, and we want to find the 3 ingredients, which is y1, the slope, and x minus x1. Okay, the x they've already given to us, it's 4. How do we find the y? We can just plug it right into here, and then we'll have the y value. So y1 is equal to the square root of 2 times 4 plus 1, which is 2 times 4 plus 1 is 9. So square root of 9 is 3. So 3 goes here into y1. And then last of all, we need the slope, and the slope is going to be the derivative of this function. I'm just going to rewrite this in a form that we can take power rule easier, because we're going to use power rule for this. The derivative of 2x plus 1 quantity to the 1/2 would be 1/2. We bring the exponent down, we leave the inside the same, we reduce the exponent by 1. Then we do power rule of the inside 2x plus 1. The power rule result would be 2. And then we cancel these 2 out, and our result is 2x plus 1 to the negative 1/2. That is our derivative. That will give us the slope. How do we get the slope? We need to plug in x equals 4. When we plug in x equals 4, it'll be 2 times 4 plus 1 to the negative 1/2. That's equal to 9 to the negative 1/2, which is equal to 1 over 9 to the 1/2, which is equal to 1/3. Okay, so 1/3 is our slope value. Okay, it's our slope. So now we can fill everything in. The slope goes there. It will be y minus 3 equals the slope 1/3 times the quantity x minus 4. Okay, so that is part A. Oops. Okay, now let's do part C. Part C has this for the function, and it gives us both the x and the y coordinate of the tangent line. So now all we need to do is find the slope, right? So again, we're going to put it into point slope form, and they already gave us the x1 value, and they gave us the y1 value right there. Now let's find the derivative so we can find the slope value. So this can be done by product or quotient rule. Let's do it by quotient rule. U is the top, V is the bottom, U dash is equal to 1. The derivative of x is 1. The derivative of V dash would be negative 3. Now we're going to plug it into the quotient rule. Remember, quotient rule looks like this. We're going to plug everything in. V is 1 minus 3x. U dash is 1. U is x. V dash is negative 3. And V squared would be 1 minus 3x quantity squared. So this is our derivative. And now what we need to do is we need to plug in x equals negative 1 to get the slope of the tangent line. Okay, so we put in negative 1 here, so it would be negative 3 times negative 1 minus x, x not x, minus negative 1 times negative 3 over 1 minus 3 times negative 1 squared. So 1 minus 3 times negative 1 is 1 plus 3, right, which is 4. So the bottom is going to be 4 squared, which is 16. This here is also 4. And this is negative 1 times negative 3 is positive 3. So it's 4 minus 3 divided by 16, which is 1 over 16. So our derivative is 1 over 16 at this point. Now we can fill everything in. We're just going to put 1 over 16 here. So the answer is y plus 1/4 equals 1 over 16 times quantity x plus 1. Okay. Number 6. Find the equation of the normal to. And so here we have this function, and they give us the x and the y value. All we need is the slope. And remember, now we're doing normal. Before, we were always doing tangent, 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 tangent. Tangent, all we do is find the derivative and plug in the x value to find the slope of the tangent. Now remember, normal is the perpendicular to the tangent, right? So like if you find a curve and it's got a tangent line at a certain point, kind of like that, the normal line is the line that is 90 degrees to that. How do we find it? We do negative 1 over the slope of the red line, and that will give you the slope of the normal line. Okay, so let's do that. We're just going to write down, as usual, the point slope form. And we already know that x1 equals 1 and y1 equals 1/4. So we'll just pencil those in there. And then now we just need to find the slope value. Okay, so first we're going to find the derivative of this function, and then we're going to plug in x equals 1, and then we're going to turn it over. We're going to do negative 1 over that slope in order to get the normal slope, which is perpendicular to that. So let's do that. So first I'm just going to rewrite this function so it's easy to do power rule on. Now some people might want to do quotient rule on it, but remember the top is not even a function. So that would be overkill. let's rewrite it as a power. So we put it in the numerator, we give it a negative exponent. Then we're going to take the derivative. When we take the derivative, we bring down the exponent, we leave the inside the same, we reduce the exponent by 1, then we do the power rule on the inside, 2x. We're almost done. Negative 4x, I'm just simplifying a little bit. Negative 3. Okay, now in order to find the actual slope of this tangent line, I am going to plug in x equals 1, right? So I'm going to put x equals 1. If I put x equals 1 in here, then it'll be negative 4, and this will be just 1, so nothing happens there. This will be 1 squared plus 1, which is 2, so it'll be 2 to the negative 3. So negative 4 times 2 to the negative 3, negative 4 over 2 cubed, which is equal to negative 4 over 8, which is equal to negative 1/2. So I'm just going to go back, and I'm going to put negative 1/2 here, and then I'm done. So it would be y minus 1/4 equals negative 1. Oops, did I remember to do the negative reciprocal? I did not. So the derivative is negative 1/2. I need to do the negative reciprocal, so I'm going to do negative 1 over negative 1/2, right? I need to do this. When I do that, it's going to end up being positive 2, right? 1 over 1/2 is 2, and the two negatives cancel each other out. So it's going to be 2 times x minus 1. Okay, and so that is the answer for A. Now let's do C. C is a similar procedure. They did not give us the y value. They only gave us the x value. So x1 is going to be 4. Y1, we don't know what it is yet. I'm just going to write out the formula before we start. So 4 is x1. How do we get y1? We can find y1 just by putting x equals 4 into the original function. Let's do that. Square root of 4 times 1 minus 4 squared. So that would equal 2 times negative 3 squared, which is equal to 2 times 9, which is 18. So the y1 value is 18. How do we find the slope? Same thing we did here. We're going to do negative 1 over the tangent line slope at x equals 4. So first thing we're going to do is we're going to find the derivative of this. In order to find the derivative of this, probably we're first going to rewrite it without the square root sign. Let's do that. So the f function is equal to x to the 1/2 times 1 minus x squared. Okay, and this is a product, right? So when we take the derivative, let's assign u to this and v to this. The u dash value would be 1/2 x to the negative 1/2. I just did power rule on it. V dash is equal to, I need to do chain rule. The outside function is squared, so I'm going to bring down the 2, leave the inside the same, reduce the 2 by 1 to become 1. Then I do chain rule on the inside. The derivative of 1 minus x is negative 1. Simplifying. Negative 2 times 1 minus x. I could also write that as negative 2 plus 2x. Okay, now I'm going to do product rule, right? So the u gets multiplied times the v dash, and the v gets multiplied times the u dash. So let's write that out. So the u, which is x to the 1/2, gets multiplied times negative 2 plus x, and the v gets multiplied times u dash, which is 1/2 x to the negative 1/2. Okay, so here is our derivative, and we would like to find the derivative at x equals 4. So we're going to plug in x equals 4 in for the x's. So that would be square root of 4 times negative 2 plus 4, which would be 2. And then 1 minus 4, which is negative 3 squared, which is 9, times 1/2 times 4 to the negative 1/2. Negative 1/2. So this would be 2 times 2, which is 4. This would be 9 halves, 1 over square root of 4, which is 2. So it'd be 4 plus 9 fourths, which is equal to 4 plus 2.25, which is equal to 6.25. This is our derivative value at x equals 4. What we want is the perpendicular to that. So the perpendicular of slope of 6.25 is going to be negative 1 over 6.25. Okay. Let's see. If I wanted to change this into a fraction, I would multiply both the top and the bottom by 4. It would be negative 4 over 25. Yes. So negative 4 over 25 is the slope. And so now I know that this is negative 4 over 25, and I already have the values for y1 and x1. Let me write it all out here. So it'll be y minus 18 equals negative 4 over 25, x minus 4. Done.